Okay, today we're going to talk about number system. So when we say number system, usually we include the binary, which is base 2, octal, which is base 8, and hexadecimal, base 16, and the decimal number, which is base 10. So for binary, it's base 2, so we only have zeros and ones. For octal, we have 0 to 7. Hexadecimal, we have 0 to none. And after none, we have use A, B, C, D, E, F. They represent 10, 11, 12, 13, 14, and 15. And for decimal, we have 0 to 9. So let's talk about it, how we convert the binary to decimal first. So binary to decimal. Let's say if we have an 8-bit binary, say for 11011101, that's 8-bit. How do we convert this number to decimal? So each the binary will have the weight. Let's do it from right to left. 2 to the 0, they have the weight 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. Now we just use, it might be easier to read if we make a table for it. So let's say if we have 1, 1, 1, 0, 1, 1, 0, 1. Okay, now this one has the weight of 2 to the 0, this one has 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. Now based on this table, we just use each bit number times the weight on that bit. So for this one, we will have 1 times 2 to the 0, and this one have 0 times 2 to the 1, and 1 times 2 to the 2, 1 times 2 to the 3, and 0 times 2 to the 4, 1 times 2 to the 5. This one have 1 times 2 to the 6, this one have 1 times 2 to the 7. Now we just need to add up all these numbers in order to get the decimal. So we have 1 times 2 to the 7 plus 1 times 2 to the 6 plus 1 times 2 to the 5 plus 0 times 2 to the 4 plus 1 times 2 to the 3 plus 1 times 2 to the 2 plus 0 times 2 to the 1 plus 1 times 2 to the 0. Now we just need the calculator to get each numbers. From here, 2 to the 7 will give us, so that would be 4 times 4 times 4 times 2. So that'll be 16 times 8. That'll be 128 plus 64 plus 32 plus 0 plus 8 plus 4 plus 0 plus 1. Now what's the total number gives us? So just need to get total from here. That will be 160 plus 68 plus 9. 68 plus 9, which is 77. So that would be, total would be 237. Now we can try to use a calculator if we want. Okay, now let's do the another example. Let's say number 2. Let's just draw a table here. Say if we have 0, 1, 1, 1, 0, 0, 0, 1. So it's 8-bit binary. If we need to convert this binary to decimal, so same thing, this one we have the weight of 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. And for each one, basically we just need to do the multiplication for ones, because anything 0 times anything will be 0. So this will give us 0, this will give us 0, 0. So we just need the result will be 1 times 2 to the 6 plus 1 times 2 to the 5 plus 1 times 2 to the 4 plus 1 times 2 to the 0. So we'll get 32. So this one will be 48. So 2 to the 6, 4 times 4 times 4, 64, plus 32, plus 16, plus 1. So that will give us, that's 80. 80 plus 33, so it will be 113. So now we know how to convert binary to decimal. What if we have a decimal number, we want to convert it to binary? So decimal to binary. Let's say if we have one example, convert 87 to binary. So we just need to, we can use this one, keep divided by 2. So basically the step is we use the number divided by 2 and we get the quotient and the remainder. And we keep use the quotient divided by 2 until we get the quotient 0, remainder is kind of 1. That's the point we stop. So we just keep going, keep using the quotient divided by 2 and get the remainder. Then after that, we just use the reverse order of the remainder. That will be the result for the binary. So let's just do it. So we use 87 divided by 2. That will give us, so if we do it as side, 87 divided by 2, 4. That will give us 873. 43, that will be 6, and the remainder is 1. So we get 43, and the remainder is 1. That will be R for remainder. And we use 43 divided by 2 again. That will give us 43 divided by 2, 4, 3, 1, 2, 1. So that will give us 21, the remainder is 1, and divided by 2 again, we will get 10, remainder 1, divided by 2, 5. Sorry, that would be 5. Remainder 0, and divided by 2 again, that will be 2, remainder 1, divided by 2, 1, remainder 0, and divided by 2, it will be 0, and remainder 1. Now we just need to go reverse order for that number, so that will give us a result 1 0 1 0 1 1 1. So that's 7-bit. In order to convert to 8-bit, we just add leading 0 to in the front. So add leading 0 in the front. That won't change the result, but will give us 8-bit binary. So we will have 0 1 0 1 0 1 1 1. So in order to test the result to see if it's right or not, so we just create another table for it. So we have 0 1 0 1 0 1 1 1. So this one, that's our result for binary. In order to test the result, So we have this table. This one will have the weight 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. So same thing, we only care about the ones. We don't care about this 0, this 0, this 0. This will give us 0, 0, 0. So we will have 1 times 2 to the 6 plus 1 times 2 to the 4 plus 1 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. So if we get this number, that will be 64 plus 4 plus 2 plus, that would be a 16. Do we miss 16? Yeah, that's 16. Let's do it again. So that would be 64 plus 16 plus 4 plus 2 plus 1. That will give us, that's 80, 87, that's 7, 80, that will be 87. So that will be our decimal number here. So they kind of match. So every time we convert the decimal to binary, after we get the result, we can do it backward. We convert the binary to decimal to see if we can get the same result. That way we can just kind of test our result, do a quick test. That's how we convert the binary to decimal, decimal to binary. And what if we can want to convert a binary to hexadecimal? So binary to hex, which is, let's say if we have 8-bit binary, let's say it's a 0, same example. Let's say it's a 1, 1, 0, 1. So if we have this, we just kind of group the 4 bits together, convert that one to hex. That will give us, so that will be 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. So every bit will only have the weight up to 2 to the 3. Because we kind of group the 4-bit binary to get 1 bit or 1 digit hex. So that will give us 8 plus 4 plus 2. So that will be 14. And this one will be 1, 2, 4, 8. So 12 plus 1, that will be 13. And if we look at the table, A is for 10, B is for 11, C is 12, D is 13, E is 14, and F is 15. So we have 14, which is E. We have 13, which is D. So convert this binary to hex. 1110, 1101 in binary, it will be the ED in hex. Let's see if we have another example. Let's say if we have binary 1011, 1001. Another example. So we just kind of group the two. Say it's 1, 2, 4, 8. So this one will give us 11. This one will give us 10. So 10 is A in hex. 11 will be B. So the result will be, for this guy, will be the binary equal BA in hex. What if we have 8-bit but it's have leading 0? Let's say if we have 6-bit, 1, 1, 0, 1, 0, 1. If we have 6-bit, we just kind of group the binary from the right side to left side 4-bit. And if we don't have 4, we just kind of add leading zeros in the front to make it 4. That way we have 4 bits. Now we can group the 4 bits together to get the hex. So that we 1, 2, 4, 8. So we have 3 here, 1, 2, 4, 8. Let's wait for each digit. So that would be 5. So 0, 0, 1, 1, 0, 1, 0, 1, which is the same 1, 1, 0, 1, 0, 1. Because we only add 2 leading zeros that won't change the number itself. So it will be equal to 35 in hexadecimal. So now we know how to convert binary to hex. How do we convert the hex to binary? Let's say if we have a hexadecimal, let's say it's a 46 in hex. What's the number in binary? Same thing, we just kind of convert each digit to 4-bit binary. So we have 4 and 6, so we need a 4-bit binary number to represent the 4 and a 4-bit binary to represent the 6. So what's the binary for 4? It will be 100, and for 6 it will be 1. So it will be 2 plus 4, since we have 1, 2, 4, 8. So 6 will be 110. 4 is 100. In order to make them 4 bits, we just kind of add leading 0 to the front, add leading 0 to the front. So 4, 6 in hex will give us the binary 0100, 0110. Okay, that's in binary. So we can just cancel out this 0 since it's a leading 0, so it will be, if we leave it 8 bits, it will be like this, but we can write it in 7 bits since we have leading 0. We can just leave that 0, still won't change the result. And same thing, if we want to just test our result, we can just convert it back to the hex. So that would be 4 and that would be 6. So that would be 4, 6 in hex. Now we know how to convert binary to hexadecimal, and we also know how to convert hexadecimal to binary. What if we want to convert decimal to hexadecimal? So let's say if we have example, let's say 87 in decimal, how we convert it to hexadecimal. Same thing, we just use that number, keep divided by the base, which is 16. So let me just kind of we get the quotient, we go to get the remainder, we keep use the quotient divided by 16, we get another quotient, and I get a remainder. We just keep going until we get that quotient to be 0. That's the point we stop, and we get the remainder. Alright, now we just need to get reverse order of the remainder. So now let's do it. We have 87. Let's divide by 16. What will give us? Divide by 16. So it's short division. This is kind of long division. So we have 5. That will give us 80. So the remainder is 7. So we have 5 here as the quotient, and we will have the 7. Let's say remainder 7. And we use 5 divided by 16 again. So the give us 0, and the remainder will be 5. Now in reverse order, we will have 57 or 57. So that will be our result. So 87 in decimal to binary, hexadecimal, it will be 57 in hexadecimal. Now we know how to convert the decimal to hexadecimal. How can we convert it back from a hexadecimal to decimal? So in order to test this result, let's say if we have 37 in hexadecimal, we want to convert to decimal. Should be 87. Now how can we do it? So for the hexadecimal, each bit have the weight of 16. For the first one, 16 to the 0, and this one have 16 to 1. So it will be 57. Let's just do a table. 57. So we have 2 digits. This one will have this weight of 16 to 0. This one will have 16 to 1. So the result to decimal will be 5 times 16 to 1 plus 7 times 16 to the 0. So it will give us 80 plus 7. So it will be 87. So that's how we convert the hexadecimal to decimal. Which is kind of the way convert the binary. Binary, each bit has the weight of 2 to the 0, 2 to the 1, 2 to the 2, and just keep going. It's same thing for the hexadecimal. It just have the base is different, so the weight will be different since it's a hexadecimal. So it will be 16 to 0, 16 to 1, something like that. So that's how we do 57 hexadecimal. It will be 87 in decimal. And it's kind of will confirm our result. 87 decimal, it will equal to 57 in hexadecimal, and 57 in hexadecimal will be 87 in decimal. Now we kind of get everything, how we convert the binary to decimal, and decimal to hexadecimal. We also know how to convert it back from a hexadecimal to either binary or decimal. So just different number system, but it's just kind of different ways to represent number. So they can just convert to each other. We have a number, we can convert it to binary, we can convert it to decimal, we can also convert it to hexadecimal. So that's kind of the basic of the number system. Thank you for watching. That's it.